Ladies and gentlemen, welcome to my shop. Welcome to my channel. My name's Keith and I'm your host. Today we're sitting in here at the base of the Sibley drill press because this is where we're going to set this job up. What we have is a Wain Roy XLS coupler. This is a attachment or a fixture that mounts on the end of the boom on an excavator or a backhoe, and it lets you change out buckets. You could have trenching bucket and scraping and different widths of buckets. I don't know what they're all used for. I'm not into that business, but I do repair their equipment for them. What we have is a bore here, and this pin actually fits in here. Kind of sloppy, so we're going to go ahead. We're making other bushings that are going to go in the end of the boom, and if we tighten this up here as well, then we've kind of made everything like brand new. Now we're going to go ahead and bore these out and then make a bushing, a hardened bushing, and the other bushings we're making are going to be hardened bushings as well. Now we can't do the crisscross grease groove that's going to be in some of the smaller bushings, but we can make adequate grease grooving in it for sufficient lubrication to get to that pin bore. All right, now we know what the project is. I had to laugh because I've been in the search of my boring equipment that I actually did that line boring on that excavator boom back some time ago over at the old shop, and off and on I'd have a flash of where I might have stashed the components, and I got the bar here, the universal link up. This is one of the key components that I needed, and this is the drive. And this fits up into the Morris taper, and then it has a cross pin that I've incorporated into it, so it actually holds it up, so I can feed the spindle down and up. So I got all the components there, and I think I actually, the flange bearings that go over the shaft, I gave one away because somebody came by the shop and needed one, and I handed it off, and so I have one on the way. But we're going to go ahead and make what we need for the support. Now before I could do any of that, I had to go ahead and make an aluminum cup and cut the insulation so that I could hold out the insulation material from dropping down, but I can also have now the room to run my spindle all the way up into the ceiling. So now I have full control or full height adjustment of this drill press, which I didn't even have that at the other shop, but I put this in a position where I knew eventually I would be able to do what I had to do yesterday. And I also ran into something yesterday. The controller on my plasma cam actually started to give me issues, so I had to send that in, and I had to manually do the plasma cutting to make that cup in the ceiling. And we're going to have to use manual plasma cutting to do some of the fixture on the setup that I'm going to do today. Okay, let me go over the plan of setting the bar up. Now we need to make this simple and easy and self-aligning to the bore of the individual item, because I'm not going to clamp this down to the base and then have a bar that's dialed into the spindle of the drill press. The beauty of being able to do this is gives you line bores in relationship to the bore location of the part, and just have the drill press do the drive of rotating your spindle and controlling the feed of your spindle or the travel in either direction of your spindle. Alright, so we have the shaft here, and I haven't even put this in here until right now. We have 3 insert holes here for insert tools or bits. Okay, one is right here, one's there, and one's right here, so that's a pretty good spacing. So I should be able to have this bar somewhat in this area right here, and I'm gonna have to mount this, and I'm gonna have to at least have whatever stick out for the travel is gonna be on the bar. And if I bring this one back here, am I gonna be in a bearing? I'm gonna run a bearing out here, and I'm gonna run the other bearing when it gets here on this side. Alright, and I need to have these bearings held off from the face of here because I need to be able to see and set or remove bits on either side of the bore. Alright, so I need to locate my bearings to this bore on each side. This is how I'm going to go about that. I always save center cutouts from flat stock that I've added in from other projects. I've laid this out in the middle here because we're going to use a manual tool to rough out a bore. We'll put this in the lathe, and we're going to machine a bore to a step bore, which will give us a face which will touch this face, and a diameter which will ride on the outside of this round here. And we're going to do the same thing with the other plate over here, and then we're going to put this in the mill, and we will put that 4-hole pattern true and concentric to that bore. Alright, so that gives us the plate mounting to here, and that gives our bearing here. Where's our space? Alright, our space is going to come into play and let us mount this to the plate via 4 double-threaded backups. We'll run a bolt halfway into here, and we'll run a bolt in from that side right there. So all we have to have is drilled holes. We don't have to do any tapping. So we got 1 register and 4 holes that we have to drill in that plate, and we can mount these bearings perfectly in line with the bore we're working on, because that diameter is good and it's centered with the bore, and this diameter over here is good with the bore. Has a little burr on it. We'll have to do a little bit of dressing, manipulating that surface to be burr free. Once we have that, then we're going to take and we're going to set this up. We'll block it. We'll take a look at our sides, see which one is less deformed than the other one. They both have a little bit of bending or deformity down in the bottom section there, but the rest of it looks pretty flat. We'll toe clamp that to the base, and then we'll pick the height, have plenty of clearance, and we'll be able to attach our bar. By attaching our bar with universal joints like this, we can be nearly in line, but we don't have to perfectly be in line. In fact, actually, when you're using universals, a slight bit of offset is recommended. Alright, that's pretty well the rundown on how I'm going to go about this. Let's get in and rough out the bore on our plates. I've already got this side scribed out on here, and the other plate is scribed out on its side, and we'll go in on the plasma cutter, and we're going to set up the manual jig because that's what we have to use, because our controller for our CNC is on its way to Colorado, and they'll take care of it and they'll send it back. They've always been good, and I don't expect anything less from them this time. Alright, this is my manual kit. I bought this when I bought my the last plasma cutter that I had before the Cutmaster 81, which I had the thermodynamics. It was an 80 amp or 80, but it was another 60 amp, but it had high freq, and I couldn't run high frequency with the plasma cam to with the computer controlling. You can't have high freq start, so I had to switch over to the Cutmaster 81, which has been giving me excellent operation since I've had it. Now, before I had the CNC, I had straight line cutting control with this. I made up some other attachments. I have suction cup and I have a magnet. I also have the pointer, and this is how I went about making my precision plasma cutting before I even had the CNC. So it's our backup, and you always say, what would I do without it? Well, you just go back to how you did it before you had it. All right. Getting a nice ground in here. I'm leaving that work area there. I cut out something here the other day, so pretty much I'm got my air set up, and I still do my draft on my table, and I cut over my table because it exits all the cutting smoke and debris and all that. All right, move my cup out of the way so I don't destroy that. Get ourselves a little vacuum. Okay, I'm just changing up my microphone here. Okay, that's probably going to be a little louder. All right, I've already set and adjusted my location from center to there. I put this wheel here. You adjust your height so that your distance off of the metal is all preset, and then you're good to go with this rotation. All right, and first off is a pierce, and I'm just going to hold back. All right, we'll get the other one done, and then we're going to take them into the lathe. Okay, we just turned our jaws around here. All right, we're going to run the first plate. This is going to be the smaller of the two diameters here. They're only about a ½ inch difference, but we're just going to bore and get a good clean hole. A little bit on the other side is always better, and then we're going to turn a register that will fit the diameter of the boss sticking out on the small side, and then we'll do the other one and I'll have that flange side. All right, move this plate out of the way. Now my bar is sticking out here quite a bit, so we're just going to shrink that back a little bit. We don't need it hanging out unless we need that full length, but we don't. All right, so we're just sliding it back. Easiest way to recenter your bar is just use the flats and the flat of your carriage. That looks like a good comfortable distance. All right, and that's all set. Okay, let's see how she's running. Hey, that's pretty. This is fluctuating about as much as that's fluctuating right there. Pretty cool. Now we're going to be locating, after we do this bore, we're going to locate that 4-hole pattern by chucking on the inside with our super spacer. So that's how we're going to create the trueness of the bore with the hole pattern. All right, just a good round hole is all we need. Okay, there's a good round hole. Alright, now we're going to go over there and we're going to measure up what our outside of our counter bore is going to be. And we're going to counter bore it slightly just to make sure that we have registering on the diameter of the part itself. Okay, the mic over the outside was 3 inches, 5/15, 5/17, somewhere around there. We do have some burrs we're going to have to file down or sand down. We're at 304, so we got a couple hundred thousandths to go yet. We're just going to bring it out. We're going to touch that bore again. We're going to set 0 there. Alright. We're going to come out 50 at a time. And then I think I'm going to plunge in at least probably, we're touching there. I'm going to set 0. Probably wouldn't hurt to go in 200 thousandths. We're going to go ahead and speed this up a little bit. It cuts a little better. Chips do fly around, but pretty soon we're going to build a shroud here. Okay, there's 200. Another 50. We're just hand feeding this in. There's another 200. All right. Another 50. Alright, let's see what we got for a diameter here. Well, we overshot that one. 3/610. Yeah, we overdid that one. Okay, she's still a little bit warm. We want to make sure she's tight because they'll shrink a little bit after it cools down. All right, so much for. That's what it looks like after you fondle your nice clean hole. I took wire feed and went ahead and went a couple times around here, kind of dressed this up with the grinder. We'll come back in and we'll claim a nice round hole because that's what we want to grab a hold of to hold the thing in the dividing head. And then we'll be a little more careful putting our register in and not overshooting it by 100 thousandths. Okay, about 498. We're going to let her cool down some. She's hot to the touch, and we want to make sure that we don't have too tight of a hole. Okay, here we go. This is at 8 thousandths here. And we're shooting for 520. We measured 515 on the tight spot. All right. We know she's still hot, and that's kind of why we're shooting that. And we got 520, 522. All right, I think that's going to be great. I'm going to put it in, and I'm going to just kiss that little chamfer right there. All right. It'll still do the job, and it's our part, not our customers. Okay, the next diameter where I can get the micrometer in on a good surface is 4 1/4, and we burn this out just under 4, and Not as close as we burned the other one, but we'll still have good material on there. All right, make sure everything's tight. Here we go. I think the insert's still good. First pass, I'm hand feeding it in here. There we go. Okay, we're still under 4. Take another 25 or so per side. Good round hole. All we need. Okay, looks like a little bit more right there. And we're at 4 inches, 36 thousandths. Okay, 227. So we only got about 23 more to go. Okay, this should give us about 5 thousandths clearance over. Yep, 4258 or so. We're doing good. Break that chamfer right there and we're ready to go fit it. Alright, taking that little burr off the edge there and then kind of dressing it up. There we go. Alright, we did the same on the other side. Now we take and we'll knock off this. That little burr right there. Alright, we're ready. We'll put them down like this on the table and we'll put that 4-hole pattern in the super spacer there. Awesome. Let's check out what hole center we're going to have, and it looks like 5 and 5/8. 5 and 5/8. Half of that is 28125. All right. We checked our index. We have masking plate for 8 in here, even though we need 4. So we got it set at 0. So we're just going to do 0, 91, 80, 270 around the globe here. All right. So first, we got to center this up. I have a couple different rings around here, but this is a pretty good ring right here. This will let me have this diameter right here to sweep in and dial it in. And this is one of my favorite rigs to run, and that's one of these old clamps that clamp right onto the spindle here. And we put this in neutral. And we're going to want to turn it around like this. Of course, that's a little bit out there. Something like this. Okay. Now, Okay, let's give it a little more pressure here. We're within the dial anyway. All right, there's 0, and that was like minus 50, so there's like 25, and bring it in closer. $70, $68, $73, $75, bring it down to like 72, 72, 72, 72. Okay, now we're going to lock down all of this stuff right here. And now we're going to watch how much it changed. Okay, we got 0 and 90. That was, minus 10 is what it was. Okay, 5, 5, 5, 5, 5. All right. Okay, we're within a thousandths right there. For a 4-hole bolt pattern we're going to put in here for these things, this is close enough. All right. Okay. All right, let's put our first ring in here. Okay, now we know we got jaws underneath here, and we may be able to get it in that pattern there. Sometimes 3 and 4 don't jive. We may have to drill partial through and then rotate it and then pick up the other 2 holes. We'll go ahead and we'll keep them square. And we're just going to go to the side. So we'll hit one, and then this one will be free. So this one will be the only one that we'll have to skip. We'll hit these, that one. Inches. 8. We're just drilling 400 thousandths through this right here. Okay, we have to lower this down. Nice. Okay, there's one. Let's do the next. I grabbed 4 of the standoffs and 4 bolts here, and we're just going to screw these down on here. By just drilling those holes out at 1/2 inch, right on the money, or 1/2 inch drill, gives you a couple thousandths clearance, but pretty well holds the true hole. All right, those have plenty of clearance around in there, and we'll probably keep these in line so that we know that we have an opening, a view, and access through these. I don't know how we're going to clamp this thing down, but I'm sure that I'm going to be able to get around, and this is probably just going to go like it is right now, but this one will be on top, one will be on the bottom. Alright, now this right here, it looks like probably 1-inch bolts. We'll screw down in here. I could probably use a little bit longer, but 1-inch bolts would be just fine. So I'll go up to the trailer and pick up some more of those. I think I'm going to clamp both of these plates on here, and we're going to tack weld these into position, and then we can start blocking this up to be held down to the bottom of the drill press here on the knee, the platform below the knee here, and we can start playing with our linkage up to the top. Took a couple of our studs, put them together. Couple toe clamps out here on the outside holding both of these rings on. The patterns are pretty close. They're not exactly lined up, but they're basically open on the 3 sides here. And we're going to go ahead and put probably 2 tacks about 1/2 inch or 3/4 inch long on 2 easy access points on here, so that we can get in here with a grinder and grind down the weld enough to break it free, and then dress it off afterwards. We don't want a weld on the face, but this outside here is open air, and it's okay to put a little tack weld in there to fasten these to the project. Okay. There, our mounting plates are ready. Alright, now we're going to layer down. We're going to decide which one we want to put down. We're going to bolt the bearing onto it so we know the bearing's hanging down. The other bearing will be on top. When it gets here, we'll put it in place. But we should be able to do most of our setup and get it pretty well ready to go without that bearing in place. Okay. We were able to get the gantry over here, you can see that, and we were able to clamp onto this, hold it up. We got this one ear, which has got a boss that mounts right down to the table on the T-nut slot, so we had the 5/8 all thread right here. We got that locked in. Then we pivoted around, and we actually had this directly under the spindle. We raised it up and down because we picked the one setup, and then we can machine this hole and we can machine this hole by just bringing the bar up and down, and we have enough travel down below. Right now it's sitting on the table, it's not connected, but it will never touch the lower foot there. It'll be up off of it. We're real close right now, and I pivoted around this direction here. We're going to have an offset here, and it's better to have an offset when you're running universal joints. If you put them straight in line, sometimes you get clatter with them running too close in line. So we offset it a little bit, and that'll be fine. They'll be able to run that way, and we're also able to use these extra long all threads that were sent in to us. So it's the first time we're able to clamp down something with a long reach all thread that we have in-house here. And there's about 1/8 of an inch to 1/4 inch gap in here, so we're going to lower our table down, and we're going to tighten this down here, and then we're going to lock the table and lock the swing of the knee support, and then our part is located where it needs to be, and that'll stay secure. And then we finish setting, raise this up, and put our bar together. We don't have that bearing in here yet. We thought we were going to get it today sometime, but UPS was here already and it didn't come. Okay, this is our driver. We're going to put it in. It goes up in there just like any other taper, shank, Morris taper, number 4. And we have a roll pin. You can see this hole right here, and that roll pin in that hole lines right up with the bottom of it's actually a little tension in there, so this will never fall out. And that's the way I retain it. In HBMs and stuff like that, sometimes they have a locking pin and an extracting pin. They have 2 slots going across for the Morris taper. Alright, so we just bring this down here and engage it so that we know it's sticking there. And we're going to go ahead and we're going to blow that out too. I haven't done that in a couple days at least. There we go. Okay, and then that goes in there, and we take our small hammer. Okay. Okay. That's all we need. That way we know it's not going to drop out of there. And also when we pull them back up, we know it helps hold it while we pull it up in the reverse direction here. Now, if we were exactly sure in lining this thing up 100%, This old drill press has got a lot of play and everything else, so it'd be really pretty hard to get it to be in direct on line 100% with this. Well, by running the universals, we allow it to track and create a center that we're creating off of the original part itself. Okay, we know this is going to come up to about here for that hole there, and it's going to have to come up to about here for that hole. So our universal joint is going to be a short shaft, not like this one here. So we're going to take another piece of shafting material. We're going to take and disassemble this one here, and it looks like we're going to have a new one. Pull this shaft out, and you can see we have a true running 3/4 inch shaft, and we mill a little flat on there, and that's where the set screws actually grab into it, so that we create a smash in spot there, and it doesn't affect the outside diameter. So we can actually pull these in and out pretty easy. So I don't really want to damage this. We might need a long one again, and I know I have 3/4 inch stock laying around, so we'll cut ourselves off a length that we need. We're going to get the V-block, and we're going to bring this up to where we want it and hold it, and we can line up these two universal joints, and we can measure on the outside how long that's going to be, and then we can make it up and then mill these two spots in it and assemble it, and we'll be ready to go, minus the bearing, of course. All right. Okay, we've got that held up in position there, and it looks like a 10-inch bar. Could be 9 7/8 or 10-inch. We'll see if a 10-inch fits in there, and we should be fine. All right, let's go find a piece of 3/4 inch rod. All right, we scrounged up a piece of 3/4 inch round, and we cut it and faced it off, and it fits in here nice. And the tool bit's up here where we're going to be able to start. I like that. Yeah, I like that. We're not too long, and I think we'll go ahead and we'll set the flats on there, and we're waiting for the bearing. So I think we're just about as far as we can possibly go getting this set up, ready to rock and roll.